All right, so last time we talked about a few building blocks in Bitcoin, and now we're going to round off and finish off the design with one big component that was left, the consensus. And I would say that that component is also the hardest to wrap one's head around, but it's very, very insightful. So we saw that Bitcoin consists of two pieces, the ledger, or some people also call it the blockchain, and cryptographic transactions on top of the blockchain. So the ledger is basically publicly visible, append-only, and immutable log. We only managed to last time talk about the hash chain, which is a component of the ledger, but we still had to talk about the consensus, which is the other component of the ledger. But for cryptographic transactions, we talked about last time, so I'm just going to very briefly remind you at a very high level what we talked about last time, because we're going to use it as a building block. So there were 3 points there, that the way we identify a person is using a public key. So the identity is a public key, and the corresponding secret key that the person has enables them to prove that they own the public key. For example, they can sign statements that are verified with that public key, and that proves that they own the public key. Now, we can do transactions where we transfer Bitcoin from one person to another by adding a signature from the sender, indicating that the sender indeed wanted to make that transaction, because signatures are unforgeable. And then remember that anybody can check a history of transactions. Anybody can check it. How? We were looking at making sure each transaction is signed correctly and no one double spent. So each transaction output could only go into another transaction input, okay? And you had to make sure everybody had, for every transaction, they had enough funds to actually issue that transaction, okay? So the point is that if you are given a chain of transactions, you can check them. Anybody can check it. And we talked about how last time, okay? So just remember this, that anybody in the world given a chain of transactions, they can verify if they're correct. Okay, so that was the building block we needed from that. And now for the ledger, there were 2 pieces that formed the ledger. One was the hash chain that we talked about last time. And the second is the consensus that we're going to talk about today. So I'm just going to very briefly remind you about the hash chain, because we are going to build on top of it in the consensus. So the hash chain, or some people also call this the blockchain. Again, the blockchain is a bit of not super sharply defined what's a blockchain, why not, but you get the idea. It's basically a chain of transactions using their hashes, or a chain of blocks using their hashes. So here you have a chain of blocks, the blockchain, and inside it you have a chain of hashes, the hash chain. So basically you have in block 3, you have the hash of block 2. Okay, and in block 2, you have the hash of block 1. So this is the hash chain because this hash is chain. They chain because the hash of block 2 contains the hash of block 1, which contains, block 1. So essentially, the last hash contains the entire history. And it accumulates the entire history inside it, which is a very powerful primitive. Why? Because if someone obtains the last hash from a trusted source, then even if they obtain the previous, the history from an untrusted source, they can check it against the trusted source. Okay. Yeah. So basically, last time so then we also said that this blockchain, which is a very long, it could be very, very long, every participant stores a copy of the whole blockchain. So if you participate with a node in Bitcoin, you are going to get the whole blockchain by default. Okay, we'll see there's some other optimizations like clients and whatnot, but ignore that. In the base protocol, every participant stores the whole blockchain, which is very wasteful. And that's because there's no central party storing it. And when someone wants to create a new transaction, they broadcast a transaction to everybody, so that everybody includes it in, appends it to their local blockchain. Of course, every node has to first check the transaction if it's correct. Okay, so remember from previous class that you can check a transaction if it's correct, correctly signed, no double spending considering what was spent so far, things like this. And if it's correct, then everybody can just create a new node, a new block, and add a transaction in that new block. But the problem is that some participants can be malicious and they might not add some transactions. But we still assume that the majority are going to be honest. Okay, so last time we saw that the big problem that we have to solve using the consensus was the following. Let's assume that Mallory pays Bob 500K for a house and she gets the house from Bob. But now there's a block with a transaction that Mallory paid Bob 500K. And she's really not happy about that block. She would like to go back in time and continue the history as before that block, because she wants that money back essentially. So she will just, because she's malicious, she will just start adding blocks from the past, as if the block where she paid Bob never existed. Okay, so now you have all these malicious users having their own versions of the blockchain, so it's a mess, right? Some malicious users have incomplete blockchains, then there's honest users that have correct blockchains, but honest users maybe didn't hear from all the honest users, so there's a complete mess as to all kinds of different versions of the blockchain. So the question is, how do users agree on the same history on the same blockchain? Okay, so the same history of transactions, which is basically saying the same blockchain. How do they agree on that?